In the previous video, I set up an object classifier with Node, TensorFlow, React, and MobileNet. Today I'm going to build on that by creating a custom classifier. I'll train it to identify a few different species of butterflies using KNN. First, let's do a quick recap of the project from the last video. I created a web app that has API endpoints. Those API endpoints take an image or a link to an image and return a classification. Each classification will have a certainty score. MobileNet, the neural network that it is currently using, is not specialized enough to recognize a range of butterfly species, at least not very well. That's going to change today. The API endpoints call on an internal function called whatisThis. That function takes the image path as an argument, calculates the image's tensor using TensorFlow, and the tensor is then input into MobileNet, which returns a classification back to the API endpoint. I'll now go back to today's project. I'll start by cloning the project from the previous video. I'll call this one Butterflix. I need to rename the project in package.json to keep things tidy. I reinstall the node dependencies with npm install. I'm also going to swap out tfjs node for tfjs node GPU. I can now dive into the index.js file. I'm going to be adding 3 new capabilities by allowing the application to train a custom model from an image dataset, save the trained model, and retrieve the trained model. I created a folder called Images in my root directory. This is where I'll be placing the training data. I got this dataset from Kaggle. I'll put a link to the source in the description. Next, I'll bring in the KNN classifier. I created a post REST API endpoint for training. Called it /train. I'm using fs to open the images directory. It's going to scan for training material. I'll return a 200 status code because training takes a while and chances are the HTTP request will time out. The source data is structured in such a way that each butterfly species is in a folder. Each folder contains a variable number of images of that species. I define a variable that will hold the classification. I use regular expressions to extract that name. I'll cycle through each subfolder with another for each loop. To digest each of the images into something that I can put through the KNN classifier, I'll create a tensor, which is a numerical representation of the image. The data I'm going to have shortly has 3 dimensions, so I'm using Tensor3D to calculate the tensor. The dimensions I'm talking about here are going to be the location of each pixel and what's happening inside each pixel in terms of its red, blue and green channels. I can then clear the tensor from memory and move on to the next one. I'm going to add a console log here, just as a helpful message. I'm going to add another API endpoint for saving the model. Ideally this should be automated, but this will do for now. For loading the saved model, I'm going to ask the app to read model.json and load it into the classifier constructor when index.js is run. I can now move on to have another look at what is this. I realize that I have to change it a little bit. Currently, it loads MobileNet and then it runs the images through it. Instead, I would like it to run the image through the KNN classifier that we just trained today. Similar to what was done in the training stage, I'm going to take the image, calculate an activation tensor, and then I'm going to feed it through the new KNN classifier. I'm going to use the predict class function to ask the application to work out which class the image most closely resembles. That's everything I need to do here in the backend. I still need to make some tweaks to the React application though, because the response format is slightly different. Model.classify, which is the function used in the previous application, returns data in this format. Predict class, which is the function that I'm using today, returns data in this format instead. There are some subtle differences. I can now rebuild the application and test things out. I'll start by installing the React dependencies. I can now rebuild the front-end part of the application. I can now go to my REST API client and call the training endpoint. This took a very long time. After about an hour, training was complete. I can now save this model by calling the save API endpoint. I'll take a look at the application. First, I'm going to give it a butterfly that it should be familiar with. Try something else. So far so good. I can now try and give it something that it is not familiar with. Let's put it to the test. I'm grabbing an image here that I have not prepared. And I'm very pleased that I was able to identify it. Thanks for watching.